Hi, this is Muhammad Al-Mohsin from CSci 572 class with Dr. Mattmann. In this demo, I will go over my setup of FacetView, Banana Dashboard, and D3 to search Solr index and visualize the results in different ways to help solve the challenge questions. This is the setup. It consists of two web servers, GT and Python CGI web server. I use GT as it comes bundled with Solr. And since FacetView and Banana Dashboard integrates and directly connects to Solr, I hosted them on GT as well. That's to comply with the same origin policy for JavaScript and Ajax requests. And for the same reason, also I hosted D3, Google Map, and Python endpoints scripts on the same built-in Python CGI web server, so that D3 and Google Map can call the Python endpoints using Ajax while being on the same server. This is how the front end looks like. I linked all components with a top navigation bar menu, and I use Bootstrap to have a unified look and feel across the board. It enhances the user experience, making all components constitute one big web application. So this is the D3 gallery. For each one, I developed a search form to search Solr index and visualize the results. The form includes a text field for the query, a number field for the number of results, and HTML5 date fields to select the time frame of the search results, and the drop-down menu to select these pre-configured polar places of interest to search in. So this is the first example, which is a D3 bubble map. For this map, I use the coordinates generated by Clavin in assignment 2 to draw bubbles on the map. So if you, for example, search for ice shelves breaking, and for example, Greenland, it will show the places or the documents in Solr index in Greenland that has mentions of ice shelves breaking during this time. So if I even change the time frame, you should have different results. When you hover over the bubbles, you will see, for example, here on this result, the author being shown and the title of the document, and if the title is not available, like in this case, it will just show the file name, and it will also show the company or organization that produced this file. You will also have the coordinates. For example, this has the coordinates 75 and -10, and this one has this coordinate. And if you click on any search results, it will open the file on the new tab. And this is the bubble map. Next is the time series. For the time series, it uses the extracted dates that I extracted in assignment 2 using Open Calais library. For each research result, the extracted dates are plotted on the timeline. For example, if you search for again ice shelves breaking, maybe for more search results, and for example Alaska this time, and in the for example, since 1990. It will go ahead, pull the results and show them on a timeline. Next is this to compare data over time. I call it compare data over time. You can compare different queries, different stuff, and then see each one when did it happen over the time. So for example, if we search for ice shelf breaking, military action, for example, oil, iron, I don't know, copper, and you hit say, and for example, you increase the search results and you hit search. It will go ahead to Solr and search for all of these queries, and then it will plot them. It will plot each one on the timeline, and if you hover over the each one of them, it will show you the numbers in each year. You can also query more results, up to 10 actually queries. Next is the collapsible tree. This will show you the search results, and it will group them by using the content type. So for this search, I got the content type, application, image, and text. If you click application, you can see that there are PDFs, Excel files, XML, Word and PowerPoint, and rich text files. For images, there are TIFF and JPEG images, and for text, there is plain text and there is HTML. If you click on any of them, it will show you the files also that represent that are of this content type. And if you click on any of these files, it will show you the actual result file or image. These are all thumbnails. Let's select this one. Yeah. Same goes for these, for example, PDF files. If you click on any of them, it will open the file. As you can see, I modified the tree to expand the height of the page as you expand or collapse the nodes here. It will expand the height and collapse the height dynamically. Next is the cluster layout. It's the same as the collapsible tree, but it's shown in a circular format. For example, this is the content type. There are images, JPEG images and TIFF images, text, HTML and plain, and PDFs. And if you click on again any file, it will open that file. Next is the word cloud. This will show a word cloud representing one of the following features of the returned results: countries, admin area 1, which are usually states, admin area 2, which are usually counties, and the exact location names and location filters, and also topic features. I used the countries and the location information from that were extracted by Clavin, and the topic features are extracted from open classes from assignment 2. So if you search, for example, for again ice shelves melting this time, and you increase the results. Let's do it for everywhere. If you search on countries, you can see which countries have this mostly. Let's search for oil. If you do by admin area 1, admin area 2, location names in general, location features, and topic features. And this concludes the D3. I added the Google Map thing when that uses interactive Google Map using the Google Map APIs. When you search for example, for ice shelves, for example, from 2010 to 2015 in Greenland, it will show you where is that happening in or around Greenland. Of course, you can switch the view to satellite or just the regular map. And if you search again, for example, in Antarctica, and you search, you should find them, the search results here. The same goes here. When you click on any search result, it will show the information for that one, and you can click on the link to open the file. Next is the Banana Dashboard. I configured the following panels here. As you can see, if you search for anything, it will show you the number of results. This is the hits panel, and you can modify the time window for your search. For example, since the year 2000, and it will just go ahead and update the results. It will all the you can choose relative, for example, in the last 10 years instead. And this is the map panel. It will show you for each country, it will show you how many results it got. You can limit your search with these facets by content type. For example, if you're interested only in PDF files, you can just constrain that by PDF, and as you can see, the number of hits is less now. You can cancel this and go back to everything. You can facet by location feature, topic feature, document author, for example, etc. I also configured these 3 word cloud, or as they call them here, tag cloud panels for the topics, location features, and location names in general. And I also did the terms, which will count how many times the terms got repeated in these search results or mentioned in these search results. I use the topic features to do this. So, for example, as you can see, flood is mentioned 81 times, earthquake 70 times, and etc. You can also see the numerical values here. This is the histogram panel. It shows the results over time. You can zoom in and zoom out as well to see more or less data, and this will actually control the timing here, the time window as well. And these are the actual results. So, for example, here we're showing I'm just limiting for the top 50 results. So this is showing 10 results, and then you can go ahead and see more results here. And I'm showing the file name, file size, and author if available, and the link to the file. Next is FacetView. In FacetView, I'm showing the results and callouts, as you can see here, instead of the regular or default tabular format. And I'm using these facets by country, topic, location, feature, main area or sub-admin area, main and sub-admin areas, which are actually the features extracted by Clavin. You can also filter by content type. For example, here are the JPEG files. You can filter by camera brand. And you can, of course, click on the links and it will show you the images. You can filter by camera model as well. If I cancel this, you can search here. As you can see, I added 2 new features to FacetView to show highlightings from Solr. So these highlights are coming directly from Solr, and I'm presenting them here. I modified the source code for FacetView to include these easily, just like when you include the normal fields. I also did the alternative fields where, if, for example, here, if the title is available, it will show the title of the search result. If it's not available, it will show, for example, here the file, the URL or the ID actually instead. And I created a pull request on GitHub, and my changes have already been merged. You can find more details of these changes on the report I submitted. Back to the challenge questions. I used my challenge questions from assignment 2. I discussed this already with Dr. Mattmann, and he said we can use the questions from assignment 2. So these are the questions. Question 1: in what polar geographical areas do we see ice sheets or shelves breaking or melting in the last decade? We can use, for example, the bubble map to solve this. If we search for ice sheets, shelves breaking or melting, and if we increase the number of search results we need since 2005 till, for example, till today, everywhere. And if you search, it's clear from the results on the map that the ice sheets and shelves breaking and or melting almost all over the polar areas in the last decade. Question 2 is: at what time frames do we see ice shields or shelves breaking or melting, and is there a trend over time? So for this we will use the same query but with the time series. Let's include this one and search everywhere. And here is how the ice sheets and shelves breaking and melting over time. It's clear that it's increasing and becoming more consistent over time, as you can see here. The next question is, do we see bears migrating around Greenland since the year 1990? Where and when? And is there a trend? For this, we can use, for example, the Google map and search for birds migration. Let's increase the search results a bit and do from 1990 to today. Search Greenland, and here is where the places where birds migration is mentioned around or in Greenland. We can use the time series again to check if there is a trend in time. And according to the search results, apparently they migrate around the first quarter of the year by following the timeline. Note that we have few years here with no data at all. If we zoom in, fewer years, you will see how the search results go. Next question, question 5, actually 4. In what polar geographical areas oil spill was discussed during the years 2008 to 2014, and show the events on a timeline. So let's search for oil spill using again the time series B3. And let's go from 2008 to 2014. Where? So the map so this shows the timeline where where oil spill was discussed during these years, and if we show it on the map, you will see where are they discussed. And here is where they are discussed. Next question, question 5. Can you predict if sea ice extent declines in Arctic Ocean will cause natural disasters? For this, let's go to compare data over time and put in these. So let's just choose some natural disasters. flood, hurricane. You can add more. Example, tsunami, earthquake, drought, explosion, and lastly volcanic eruption. Let's increase the search results here. We want this in Arctic Ocean since 1960 to, for example, as in 15. To go ahead and search for each of these keywords and show you the results over the years. And as you can see, natural disasters mentioned in the query coexist with decline of CSci extent as shown on the map. The coexistence is consistent over the time, as you can see, and it's becoming more condensed towards recent years. And with this consistent and steadily increasing coexistence, it's predicted to see more and more natural disasters coming in the future. Moreover, when showing these topics associated with the sea ice extinct decline, if you go and show them on a word cloud, if you show the topic features, you will see that many of the topics standing out are like natural disaster, like flood, storm, drought, earthquake, explosion, hurricane. All of these are natural disasters, and they are standing out. So it is it is coexistence with this. We can also see this in the Banana Dashboard if you search for also sea ice extinct decline. If you search for this, go here and see the topics on this donut diagram. You can see that the flood, storm, earthquake, drought, fire, hurricane, all of them are among the top results here. Going to question 6. What documents are most relevant to ice sheets or shelves breaking or melting in the last 3 decades in Greenland? We can go to, for example, Collapsible tree and search for ice sheets, shelves breaking, melting, and let's see, for example, the top 20 results since 1985 till today in Greenland. And if you search, you can see the top results here, organized or categorized by the content type. This shows the top 20, and if you click on any of the search results, it will open the file for you. And for the last question, what documents are most relevant to birds migration around Alaska since 2012? So if we go and use this, for example, the cluster layout, search for birds migration, let's show the top 20 results since 2012 till today in Alaska. You can see that these are the top results, and if you click on any of them it will open the file for you. This is an Excel file, so it's just downloaded it, and here it is. And if you increase the number of results, it should show you more, if available, of course. And that's it. Thank you.